So I'm Fatema, I'm a data scientist at DHL Consulting, and then today I have the honor to chair these two sessions, this one and the one after. And we will hear from Florens Greßner about enable trust in AI through testing. So Florens has a background in mathematics. He dived deep into the abstract side of mathematics, but then he decided, okay, it's good to also see some real-world application of math, and he believed that the machine learning suffers from profound mathematical understandings, and that's why at the age of 22 he co-founded his own company called neurocat. Very interesting name. Maybe you can elaborate on that also. And then, yeah, he co-founded his own company, and maybe just a very brief introduction to the company is a consulting industry in risk assessment, robustness, and interpretability of AI systems. He has already worked with different sectors, including automated driving, voice assessment, and virtual sensors. So I will give the stage to Florens. Please, a round of applause for him.
Hi everyone, thanks for the nice introduction, and I also believe this is a nice touching point to the previous presentation, because we are also talking about regulations, about trust, and which kind of test methods you can use in order to comply. And yes, so my name is Florens Greßner. I am co-founder and CEO of neurocat. We are focusing, so we are not training any ML models, we are focusing on assessing the risk of those ML models. And we did this over the last 5 years, had a lot of projects together with customers where we implemented some testing strategies for them in order to enable a systematic assessment of risk and also provide guidance towards mitigating them. And recently we received a strategic investment from DSpace, and they are supporting us now bringing out our test platform aidkit. I will briefly mention in the talk. So basically, neurocat, we want to enable trust in AI. And this is not because we are afraid of some kind of singularity or that we are afraid that AI will take over humanity or something like that. No, we believe we can only unleash the full potential of AI when it's done, when it's deployed properly, and when you can be absolutely sure that it works and that also society can trust it. And we believe this can only work to unleash the full potential if we can also go into every use cases, also the mission critical, the safety critical, and the security critical use cases. And we want to empower these ML engineers and these ML pioneers to deploy into every relevant use case that we can unleash the full power. So we talked about safety, we talked about security and mission critical AI systems, and now we are seeing there's the AI Act coming out. So the European Commission is starting to think about, okay, hey, how can we regulate these ML developers? And they figured out a taxonomy, and these ones extends actually the use cases that are really high risk. So not only automotive or medicine anymore is high risk. After this is mandatory, it gets very much extended. I just wanted to show you here in this pyramid, it's like basically the risk pyramid, where they distinguish different use cases in unreasonable risk, basically that is against European values, like credit, social scoring or something like this, and anything that endangers the safety of the European citizen. And there are high risk applications that I will mention now, and also lower risk applications that are rather going in the entertainment industry, but might also need some interpretability, so some minor requirements are set for them. And these use cases are basically anything related to critical infrastructure, so oil, gas, water, and transportation in general. Also scoring, so if you apply for a job or for an education or for a credit, this is seen as a high-risk application. And anything related to law enforcement, so if you're wanting to look at some evidence and figure out if this evidence is sufficient enough, in order to enforce law. This is seen as a high risk from the European Commission, border control and biometrics, anything related to that. Public services, so the whole apparatus of bureaucracy, and anything that is already like a safety component. And these comes into the category of high risk, and all of these use cases are going to be regulated by this AI Act. The draft of it is already published right now, and it will be decided on this year. Then there will be some transition period, where it's not mandatory and people can try it out, but then soon, and approximately in 2 years, it will become mandatory, and it's very important to prepare beforehand that not anyone is surprised in the end. So unreasonable risk and no risk at all, I just scratched out, but what happens to these use cases that are categorized as high risk? These need to fulfill certain quality requirements, and I want to briefly mention them. So basically, you have to have a systematic approach on testing and assessing risk. I will go into detail on that later. You also have to have a systematic approach on how to mitigate risk. So if you find any defect, you have to have a systematic and automated approach on how to resolve that defect in your system itself. And transparency and interpretability is a very huge topic that needs to be fulfilled, that everybody who uses it, or maybe if somebody checks it, can understand what is going on. This will be also the focus of my talk, and what we also gained a lot of experience over the past 5 years by exactly working and trying to deploy systems that are mission critical and safety critical. But just to be complete, also more requirements, and also a nice touching point to the last presentation is you need to implement some data governance where you basically have to argue why your data set is sufficient enough and big enough and covers all the relevant conditions. You have to document every architecture and every training procedure you are using, everything related to ML, log every event that goes in and out of your system, and design the system in a way that you can implement some human oversight, that a human can always intervene in case of a critical scenario that might happen. So we've seen there are use cases that are also quite new that didn't have a touch point with safety and security before, but now with this AI Act, and there are also other standardizations outside right now, but this is the most prominent one that we are seeing right now, and also the one that we have the feeling will be the fastest. And I want to elaborate on how we, I only want to focus on the first 3 points here, and I want to elaborate on what we did the past 5 years with our customers in safety critical environments, how we helped them with designing a test strategy and a mitigation strategy that can also help these new cases to comply with newer upcoming regulations that might come. So basically this is all under the frame of a test strategy. So a test strategy is something where you need to define quality requirements and probabilistic thresholds you need to exceed in order to be able to deploy the system safely. You have to define a test approach, how you want to systematically assess the risk of the system itself, and give an idea on your defect triage. So the risk mitigation itself, what happens if you face a defect, what are you doing then? What is your systematic approach behind that? And one very important point that is for any testing strategy is the automation strategy behind it, because if there is only a human testing it, this always leads to flaws, and if you have some budget cuts, then you have to decide on, okay, which test do I want to execute and which test do I don't want to execute, and this is not a thing that is allowed in a safety or mission critical environment. So basically, let's start with the quality requirements, and also the nice thing is also in the AI Act, this is a clear point you have to do, defining probabilistic thresholds, and that is basically your quality gate for which you can decide if you want to deploy a model or not. So how does this look like? How does this process look like? First of all, you need to define some statistical confidence. So this in the end tells you how sure you want to be that your tests are correct. So in the automotive industry, it will be some 9s after the 99%. In the medicine area, it's much higher. And for every use case, it might be different. But this will decide in the end how much data and how much test methods, how much data you need and how much test methods you want to execute in the end. You have to select data and severity metrics. It might be given from a technical standard, but this is a standardized process to decide on if you inject noise into your data, how big is this noise? You have to figure this out somehow and measure this and quantify it, and also measure the damage that happens when you face a misclassification itself, and define the relevant scenarios. So in automotive, for example, a relevant scenario could be some kind of weather condition, a system should work under rain, under sunshine, and everything. Maybe an NLP system needs to work even if a user introduces some typos and swapping of some characters. So defining this relevant condition will be very important in order to understand where do I might need to improve my system in the end, and set the quality thresholds for each and every scenario that needs to be used with the data and severity metrics and should satisfy the statistical confidence in the end. And this is basically the first step before one can even start to test in a systematic manner. And also in the AI Act, like I mentioned, probabilistic thresholds are mentioned very explicitly. So after you define all your quality requirements, the next step is how are you testing at all and what is sort of very important. And here I just want to zoom into one very important point that I find I'm always facing and finding with customers who are working together, because in ML, also in the MLOps platforms, performance is basically the metric, and there are different kind of metrics that measure performance that tells you how successful your model is. And I just want to show you what the problem with performance metrics is in a high-risk use case. So basically, we understood we have to define relevant scenarios and relevant conditions. So to make it very easy, and I apologize that I need to use formulas, but I believe we are very tech-driven here, that I am allowed to do so. Let's say we only have 2 relevant conditions to make it very easy. We have clean data, so data you experience in your training process and every day, and you have some dirty data. It could be some edge cases that might happen very rarely, but your data has 2 relevant conditions. It must work under clean and it must work under dirty, not dirty, but dirty conditions. So what you might find is in an edge case, this only happens very rarely. So one can assume this dirty data might have a very, very low probability of exposure, and this clean data happens very, very often. And the problem that is happening here is you defined your performance metrics, and you now applied your performance metric on every single data point, and you use even this performance metric to optimize your model in order to maximize this performance. What happens in the end is you have these green data points that happen where you're exposed to very, very often, and then you have this rare data point that your algorithm doesn't really need to care about if you only look at performance, because it happens very rarely, and if you take the mean over all performance measures, your algorithm does not need to optimize to hit every single data point. But this pink little data point could be a pedestrian on the street, it could be a very severe condition, and this is not sufficient to say, hey, this is fine in a high-risk application. This is not possible. And let's look in contrary to what risk is and how to measure risk in the end. So to the contrary is risk is basically severity times exposure. So how bad is something and how often does it happen? If something never happens but is very severe, you don't really have to be concerned with it. If something is not severe and you are exposed to it all the time, it's also really not important to capture this. But if something is really severe and has a low probability of exposure, then you have a very high risk in the end, and you have to be taking care on these pink little data points that might be dirty, might be edge cases, but only happen very rarely. And this basically contradicts itself, because this formula is not really captured in this performance metric. And in order to deploy a high-risk application, you need to care about every data point that is highly severe. So taking into account, we need a severity metric that tells you for every relevant scenario how severe this could be. And applying a risk measure that takes this into account, severity times exposure, and not you optimizing for this performance, where this pink data point is not important at all, but also improving the importance of this, can lead to the decision boundary being pushed toward that also this rare data point is important. And this might happen if you are looking at every relevant scenario separately and take care that you have a significant amount of these data points in your data set, or that you need to augment it in some kind of way. So what I didn't tell you is how do these pink data points look like, how do they appear, and how do you can use them in your training and in your risk assessment, and might even use them in the optimization of the system itself. So these data points happen, I told you, there's a big difference between training data and the data in the field, so the real world data. If you're deploying your system, you might be exposed to noise, you might be exposed to unforeseen weather condition or unforeseen edge cases that you didn't take care in your training set. And in other scenarios, so this is more the safety side of things, and the other side is the security side. And there's an active community of persons publishing adversarial threats and adversarial attacks, basically that are open source and everyone can use to tamper with a machine learning model and introduce very tiny noise on a data point that is not visible to a human being. Maybe it's just a pixel that is flipped or a small overlay that is invisible for a human. And this tampers with your model. And here's one severe case of this. We're seeing like two pictures on the top, one person on the street, and on the first one it is detected, but introducing tiny noise to it, it's not seen at all. And how can we trust a system that behaves like that if that we cannot comprehend as a human? So this is how these data points look like. Now it's the question how to get to that, how you can assess if you are also good enough in these conditions. And in the end, and there are like two different streams of test methods one can use. And this is basically corruptions itself. So also in the robustness literature of machine learning, corruptions are an important factor and a test method in order to deploy high-risk application. It basically is a simulation of these relevant scenarios, maybe an overlay of rain, an introduction of noise, or if you're in an NLP system, a swap of characters. So introducing and injecting noise into your data points that are already present in your training set or test or validation set. And the second point is, I told you, they're open source repositories. It's very publicly and very active community that publishes adversarial attacks. And in the end, it's a cat and mouse game. There will be a new attack published, there will be new defense published. And in the end, you have to decide what kind of budget an attacker needs to exceed in order to tamper with your system, because any complex system can break eventually at some point. And augmenting your training set, first of all, with different adversarial examples or corruptions leads to this graph that I showed you, exceeding this decision boundary and also taking care of these rare data points that you might be not able to capture in the real world very often because you're not exposed to them, because they are very improbable. So this is how these test methods and how these augmentations are looking like, and this can be differentiated in two categories. So defining the test approach, we understood performance for high-risk applications is maybe not a good idea, and risk is the most essential part for everything, and there are test methods you can use to figure out that you have a problem and even to improve your system. But improving your system is more topic of this defect triage and the mitigation of the risk itself, and I just want to tell you about this process, how it's being done in safety and security critical application and use cases. So we've figured out vanilla performance is not sufficient. So this is like the first point in order to detect a defect at all. You have to test against every relevant scenario in order to find a defect in some certain scenarios that you might have to take more care about. For every of these relevant scenarios, you have to check if the quality requirements are met. And if they're not met, then for this relevant scenario, you might have to augment more. You might have to find training procedures that are improving your system in this relevant scenario and optimize for risk, or like minimizing risk instead of optimizing performance is here the key to success in the end. And this might lead you to updating your architecture or your training procedure. There are a lot of defenses out there to protect yourself against these corruptions or adversarial attacks in the end, and then test again until quality requirements are met. This sounds straightforward, but also very abstract and very, very high level, this process. But it's not a complete abstract thought. It's very concrete procedures you can use in order to minimize risk. The optimization method needs to be adapted, and risk has to be taken into consideration in order to achieve this. So this is not an abstract thought. This is something one can really implement. I will not go too much into detail about this because I rather want to focus here on the overall test strategy that needs to be implemented for these use cases. And in the end, the automation strategy that is very important because the MLOps workflow is very much automated, and automating tests is always a good idea and necessary in order to have reproducible results and not to face any budget cuts where you cannot execute some tests anymore. So in the automation strategy, first we have to ask ourselves, how does the workflow look like in MLOps? And I believe it crystallized that there's one very standardized process how ML is trained right now. So there's the first step where you process the data. You're collecting data, you're annotating data, cleaning it out, and selecting the one, separating it into test and validation set, and selecting the one that is relevant for your use case. Then you develop a model, figure out what architecture you want to use, what hyperparameters and training procedures, and then directly throwing compute power on it and training a model. And what I mentioned before is in these MLOps life cycles, in the validation phase, this is very heavily focused on performance. So this is the current process, and I want to suggest one improvement to that. And if you're satisfied with the performance of the system itself, and if it's not safety critical, then you can basically deploy it. But now you are in a high-risk application because the AI Act might come out and you have to comply, and because you are in these high-risk use cases. So what are you doing then? You need an automated workflow that provides you with all these test methods and these risk scores and these risk metrics in order to make a real decision if you can deploy this high-risk application. And our proposal to this problem is a software tool that we call aidkit that contains all of these test methods, relevant corruptions, relevant attacks, testing and stress testing against these relevant scenarios, and then making a real decision if the risk is low enough that it satisfies the quality requirements for every relevant scenario, and then can go into deployment for the high-risk use cases. And what is very important is that it's easy to integrate into the MLOps workflow in this automated workflow, because it directly sits in it and can be directly accessed via APIs and Python clients. And it is your robustness and explainability expert at your fingertips that keeps you up to date with the standards, regulations, and the newest risks that might be introduced as a corruption or as a adversarial attack. And to recap also what we talked about, clicking all these test strategy together is basically just a few clicks away by defining these quality thresholds, defining the methods, the test methods that are relevant for you, selecting the relevant scenarios where you set your quality thresholds and your probabilistic thresholds to it, and leads you then to an actionable report that helps you to understand in which scenarios you might need improvement, suggests you the data that helps you to improve this in order to minimize the risk for your use case, and then helps you to infer if it's possible to deploy the system or not. And we put all our experience from the last 5 years in safety and security critical use cases inside of it, and hope to make it very easy to comply with it, that we can focus on innovating and implementing all these use cases and unleash AI's full potential. So just to recap, AI Act is coming out, will be decided this year, it will go in a trialogue, and there will be a transition period, but in latest in 2 years it will be mandatory, and one has to comply if one is in these high-risk use cases that I mentioned in the beginning. And in order to comply, you must have a systematic approach to test the risk and exceed your probabilistic thresholds. If you find a defect, you have need to have a systematic approach how to mitigate this risk and how to overcome this defect, and provide transparency and interpretability. I didn't mention it in this call, but also aidkit provides interpretability methods that help you also to debug why certain things are not going right. And one thing that I forgot to mention, but is very important because it's very catchy, we propose aidkit till you make it, testing through your whole MLOps pipeline until all the risk requirements are satisfied. And today, I hope we can lift the data, and I would be very interested if you might be in one of these use cases, how your test strategy looks like, and I'm very interested to learn more about all the use cases that you're using. Thanks a lot.
So thank you, Florens. Very interesting. So now we have 5 minutes for questions. Anything? Yes. Here first and then second. And please wait for the microphone for the sake of recording.
Hi, thank you for the talk. So it's kind of like, so the risk assessment is kind of like algorithmic fairness also, where you have to include those outlying data points. And the problem there is that often then the overall model quality actually worsens through that. And so do you have any thoughts on that, on how to maintain it?
Sorry, if I understood you wrong, you're talking about the trade-off between performance and robustness, basically. Yes, this is true. There is a trade-off between performance and robustness, and it makes it even more important to not optimize for only one metric, but to optimize for multiple metrics and take all this into consideration. And the only way to do it, I mean, basically, we are having universal function approximators that should be able to train on a robust and a performant model. So basically, in theory, it is possible, but only looking at one metric and optimizing for one metric and hoping that it will comply with all the others is, I believe, not a good strategy, and different and rich amount of metrics need to be used in order to satisfy multiple requirements. Yeah? Does this answer your question? Okay, cool. But we can also catch up later.
Yeah. Hi. Thanks a lot for your presentation. I just wanted to ask how, if there is any strategy about that, we can be sure that we found all the relevant scenarios, because it looks like that it's really dependent on that. Otherwise, there is even the risk that we didn't find the relevant scenarios, and then we are back at the starting point.
That's absolutely true, but that makes it more and more important to also define a structured and systematic defect triage. So if you are experiencing use cases or like scenarios that you didn't thought about, it is more and more important to also be able to just implement them if you experience them. I mean, it will not be possible to capture all the relevant scenario at the first try, but beforehand assessing the risk, understanding what kind of environment am I exposed to, and understanding what kind of things could go wrong, and defining this in a systematic process, and then also taking care of your defect triage, and defining this process is the way to comply with it, and you will not be able to find them all at the first stage, but it, in the end it will boil down to industry best efforts. Yes.
More questions? All right, thank you, Florens. Once more, please. Another round of applause. So make sure you be back for the next session. I think it's at 17:40, yes? Yeah, okay, perfect.